Okay, so let's go through some of these more complicated ones. So this guy, if we want to simplify, we have two options, okay? So when I look at this one, I see, okay, what are my strategies I can take? Well, one strategy you can take is you're always welcome to simplify in the side of the brackets if you'd like, first, okay? The other thing I noticed is there's a negative exponent, and is that negative exponent applying to everybody? Yeah. So in this case, it's a really good idea, and I like to get rid of negative exponents. They're kind of ugly. How can we get rid of that negative exponent with the 2 right here? Flip what? This whole fraction. Does that change the numbers? No, it just takes the reciprocal. Everything's the same, but it's the reciprocal. Okay. So we still will have, so now our exponent will be positive, and it would be the exact same numbers, just the reciprocal. Okay? So the negatives on the inside still are negative because we didn't take care of that negative. We only took care of the outside negative. Okay? So everything, when we flip it, everything stays the same that it was before. Okay, so now I'm looking at this. Again, I have two options. I could either simplify inside these brackets, or I could bring in that exponent and apply it to everyone. Simplify inside the bracket, sure. So that's 6 and 24, right? 24 doesn't go into 6, but if we can, we reduce the fraction. So can we reduce 6 over 24? 1 over, we divide both by 6, 1 over 4. Okay, so we're going to write that as a fraction, 1 over 4. We've reduced that. We divided both by 6. Okay, what are we going to do here when we're dividing our x's? Subtract. So we have 3 minus 2. That's pretty easy. X to the power of 1, just x. Negatives are always tricky, right? This is where little mistakes happen. So our y's here, we want to subtract. So positive 3 because we have negative 1 minus the negative 4. And when we subtract a negative, it's really adding a positive. The two negatives become a positive. So negative 1 plus 4 is 3. Okay, we can't simplify inside the brackets, so we have now, what do we do? What do we have to do now? Apply the 2 to everyone, including, don't forget, the quarter. Including the quarter. So a quarter is going to have power of 2. We apply to everybody. X will become what? X squared. It was a power of 1. Power to power, we multiply. And y to the power of 6. Yes, Anthony? Okay. So we need to square the quarter. So really that's applying both to the 1 and the 4. So 1 squared is 1. 4 squared? 16. And now we're done. Okay, there's two ways we can write that answer. You can write it like this, or you could write x squared y to the 6 divided by 16. They're both the same thing. Okay, those are both the same, right? Because the 1 would be on the numerator, 16 on the denominator. Okay, those are the same thing. Because they're positive exponents, so they'd be on the top numerator. If they were negative, we'd move them to the bottom. All right, let's look at C. It's kind of ugly. Yeah, you probably wouldn't have something, there's lots of great concepts in here we're going to cover, but probably won't give you one this difficult on your test. No, let's do it because there's really great concepts. If we can master this, then you're going to be really comfortable with your questions on your test. So there's two options, okay? We could bring in the negative 3 right now and the negative 2 right now, okay? Or the other option, so we can take care of this exponent here and this exponent here, those two negatives. Okay, now that negative on top, is it applying to the 10? No, because it's outside the bracket. So 10 is going to remain where? And where else? on the top. So 10 stays outside still and the numerator. So this guy we're going to put to the bottom. These two are going to switch spots so that they now have positive powers. So the 8, everything inside stays the same because we're just taking care of the negative exponent on the outside. Okay, so this negative power, we're going to flip it. So that means this all moves to the numerator to become positive. This negative power, we're going to flip it. It means it all moves to the bottom to become positive. Just that outside power. Is that okay? Okay, it was pretty ugly. So now it's going to be a lot easier. Now we took care of those ugly negatives. What would we do now? Pi the powers. Yeah, we can't, these aren't in the same bracket, so we can't simplify yet. So we have to apply the square. So in the numerator of 10 times, the square applies to everybody, including who? Nope, does it apply to the 8? The 10 is not inside the bracket, so just the 8. 8 squared is 64, thank you. I almost thought 16, I don't know why. So 10 times 64, p to the negative 6, because negative 3 times 2, q to the 5 times 2, 10, and r to the 6 divided by p to the power of, no. So now we're doing cubes. 3 times 3 is 9. Q to the power of 6, and r to the power still of 0, because 0 times anything is still 0. Would you actually even have to write that r? No, it's equal to 1. Yeah, we can leave it for now because we're simplifying. Okay, now what can we do? Yeah, we can now, we have division. So what are we going to do with our powers? Subtract. I can also go 10 times 64. 640. P to the, so negative 6 minus 9. Negative 15. 10 take away 6. Q to the 4. And r, 6 minus 0. 6. Okay, what's wrong with this picture? There's one thing wrong. Negative exponent. So who's going to the bottom? P. So Q and R stay in the numerator, and P, U, no, just P, moves to the denominator. All right? It wasn't so bad, like, after we took care of those negative exponents. Just that first step. Yeah. How did I get negative 6? How did I get negative 15? So with the p's, it was negative 6 take away 9. So we have negative 6 take away 9. So that's why it became negative 15. Yeah? It is. Number to the power of 0 is 1. So even if we didn't write this r here, you would have still had just r to the 6. So it would still be the same thing. No, because it's not r to the power of 1, it's r to the 0. And we're just subtracting the exponent, so 6 minus 0. Guys? Okay. So we're just subtracting the powers. So even though if this is 1, then you wouldn't, if you actually just evaluate this as 1, then this r is gone. And so you wouldn't be subtracting, it would just be r to the 6. No, because 1, you don't have to. If it's multiplied by 1, you wouldn't have to. Right? Because anything multiplied by 1 is just itself. Okay? All right, flip over to page 74. 74. And we covered H yesterday. So we're going to look at G, I, and J. Oops. Oopsie. Do you want to try G on your own right now? Or, yeah? Okay, try G on your own. And then we'll go through it. Now, we're on page 74G. There's multiple ways to solve this one. So the way I'm solving it might look very different than how you solve this. Okay? So you could have simplified on the inside first. You could have brought in the -2 to everybody first. Okay? I see this negative on the outside. It's applying to everybody. So I'm going to actually flip it right away. So I'm going to write this. Everything stays the same inside. It's just the reciprocal. Okay? Now, from here we have two options. We could either simplify on the inside right now, or we can bring in the square. Who brought in the square at this point? Yeah? No? Who simplified first? Like did the division inside first? Yeah, so either would work, okay? I'm going to bring in the square because a lot of you did. So this square applies to everybody inside. So 6 squared is 36, m to the 4, n to the 4, and then 2 squared, 4, m to the -6, n to the 4. Okay, now there's two options here. You could take care of this negative exponent by bringing him up if you'd like, or I see everything is division, so I can use the subtraction method. I'm going to subtract 2. 36 divided by 4, yeah? -6, yeah, because your powers you multiply. Okay, so when I divide 36 divided by 4, 9. 4 minus a -6. 10, because you're subtracting a negative. So +10. And 4 minus 4 for the ends, what does that give you? 0. So it's just 1. So they actually just cancel each other out. You wouldn't write n to the 0 because it equals 1. That should be your solution. No, you want to die? I might take off a mark. I might not. Half a mark. Okay, I'd like to go through I with you. Okay? Do you want to? You can try it on your own if you like. Or do you want me to go through I with you? By yourself? By yourself. Try it by yourself. I'm just going to help you with the first step. There's no exponent laws for addition, so we have to actually just evaluate them individually. Okay, so maybe I will go through this one with you. 1/4 squared, because you have a negative exponent. Oh, you cannot flip the entire thing because it's not multiplication, because of the addition. Yeah, that's why I wanted to go through this one with you. Okay, so this is our numerator. So 4 to the -2 is 1/4 squared plus 1/4. Right, because 4 to the -1 to flip it, 1/4 to the power of 1 over 1/4 squared. Now, can these just cancel out here? No, because of the addition, they can't, only if it's all just multiplication division. The reason why in multiplication division things can just cancel out, guys, is because in BEDMAS, does it matter the order you do multiplication and division? No. You can do them in either order if it's just multiplication and division. But if there's addition there, because there's actually invisi brackets here. You just can't see them, right? In this numerator, we have to add this before we can divide. Yeah. Okay. Yeah. So what is 4 squared? So we have 1 over 16 plus 1 over 4 all over 1 over 16. Because 4 squared. Yeah. Okay, what do you need to add those? Common denominator. So we're going to multiply top and bottom of this guy by 4. So what does it become? What does it add to on the numerator? So we have 1 plus 4 over 1 plus 4. 5/16 divided by 1/16. Okay? When you have that, that's pretty ugly. Agreed? Well, no. No, 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 no. Instead, just write it the way you're used to seeing it. We have 5/16 divided by 1/16. Right? Remember, this symbol is the same as that, just written differently. No, no, no. You didn't do your brackets right. Okay, so when we divide, what do we have to do? Flip the second guy and times. Okay, so we multiply through. These are actually going to reduce out, so it equals 5. Because of addition. Okay, now could you actually type this into your calculator? How would you type this into your calculator? Brackets. Because this is just multiplication and division, Joel, right? There's no addition anymore. It has to simplify. That simplifies to 5. Because 16 will go in 5 times. Why is it frozen? Exit, reset. Let's try that. There we go. Okay, so in your calculator, you need brackets around your numerator. 4 to the, remember when we use negative, you have to use the negative button, not the minus, or you'll get an error. Plus 4 to the negative 1, guys. And then divided by 4 to the negative 2. That's 5. Okay. All right. Last guy. Can you solve this one? There's words. That's okay. You want me to read it to you?
Yeah.
What's your name? How do they cancel out? Because in multiplication and division, you can do them in any order. So these actually will end up canceling out because there's one on the numerator, one on the denominator. You don't have to. You can multiply through, get 80 divided by 16, which will equal 5. Okay? So the amount of energy in kilojoules E a student is given by that formula, where S is the number of hours of sleep, P is the number of grams of protein, and C is the grams consumed, yes, of sugar. Thank you. Okay. So they tell us, find the amount of energy Mira had if she sleeps 8 hours. So that means her S is 8. Guys, ate 10 grams of protein, so P is 10, and consumed 100 grams of sugar, so your C is 100. Okay. It's a matter of just plugging it into the formula. So go ahead and plug that into the formula, see what you get to the nearest 10th. Guys, what do you have to remember when you're typing this in? Brackets. And also you have to remember brackets when? A fractional exponent, unless you have a fancy calculator. So brackets around our numerator, brackets around our denominator. and brackets around the fractional exponents. So bracket 8 cubed times 10 to the power of bracket 1/2. Close the bracket for the 1/2 and then close the numerator. Divided by bracket for the denominator, 100 to the power of bracket 1/5. Close the bracket for, okay? Okay. So I typed it in properly. So check how you typed it in. I can come look at your calculators too. You should get 644.6 kilojoules. Okay? It says to the nearest tenth. Yeah. So you'll have a question for sure like this on your unit exam. Yes, Joel. Let me see your calculator. Your calculator's different? Oh yeah, so you use arrow. So you still need a bracket around your numerator. 8 cubed, arrow to take it down, times 10 to the power of 1/2, arrow to bring it down, bracket divided by bracket. Okay? If your calculator raises your exponent, it's different. So if yours raises it, let me know. Okay? Oh, you forgot your power of right here. There you go. Okay, your homework for today, if you grab your workbooks, on page, can I borrow this? Page 75, 76, and 77. Okay, the answers are on 78 and 79. Okay, so those 3 pages, yeah? No question? Okay. Also, if you finish early, or if you would like to take home a practice exam for the weekend, they're on the side table. And the test, so we're going to have a practice exam on Tuesday. Wednesday is our test. All right? You have a long weekend to study if you like. Okay, I'm just going to stop this.